Hi everyone, my name is Maribel. Today we're going to be learning about the touch sensor. So last time we became familiar with the ultrasonic sensor, which allowed our robot to measure distance and was even able to follow you. So today we're going to be using a different sensor, the touch sensor. So what uses do you think the touch sensor has? The touch sensor we use because it allows the robot to have its own hands, so to speak. So what that means is that the robot can now touch objects, it can know where they are, and it can react to them. So we're going to be using a touch sensor in our robot today. Now, when we're building our touch sensor, there's something very important that all robots have to consider when they're being built. So if we have an object and we have our touch sensor, the sensor will touch the object if it's pressed against our sensor, and then it'll react to the object. But we run into some problems when the object is a lot smaller, or harder to touch. So if we have our sensor and we have the wall or the object, but it doesn't touch our sensor because of the size, then the touch sensor won't react to the object. Hi everyone, my name is Maribel. Today we're going to be learning about the touch sensor. So last class we became familiar with the ultrasonic sensor, and we saw that it was able to measure distance and even follow you. So today we're going to be learning more about the touch sensor, and we're going to be building it onto our robot and creating a program so that it can react a certain way once the touch sensor is touched. So why do you think the touch sensor is useful? It acts as the robot's hands. And by that I mean that it's able to detect objects and react to them if the touch sensor touches the object. So for example, if we have our sensor and we have the wall or the object, the sensor will touch the object and it'll know it's there and it can react a certain way. So if it was trying to avoid a wall, it would touch the wall and then we can program it to avoid the wall and go around it. But there's a small problem with touch sensors. You can see that this is a touch sensor, and if it touches an object, then it'll react. But what if we're trying to find an object that is really small? If the object is really small, our touch sensor will likely not detect it because it won't be able to touch this center of our touch sensor. So when you're building a touch sensor, or when you're building a robot with a touch sensor, it's very important that you add parts to it so that your touch sensor has a wider surface area. The wider the surface area of the parts that connect to your sensor, then you'll have an easier time detecting smaller objects. This is going to become a lot more clear when we start our build. So let's talk more about the touch sensor. The touch sensor has two different statuses, pressed and released. So we can program our robot to respond to three different states. The first is that when it's released. So we can have our robot do something when there's nothing touching the sensor. We can have our robot do something if it's pressed. So that's the second state. And the third state is we can have our robot do something when it's pressed and released. So we're going to be working with all those states in our program today. So with that being said, let's get started with the build. We're going to first work on building our touch sensor, then we'll build the robot, and then we'll attach the two and then get started with the programming. So to start with your touch sensor, we're going to take your touch sensor, 2 cross blocks, 2 axle 3s, and 2 black pins. Put each black pin into the pinhole for each of your double cross blocks. For one cross block, put the axle in the left So let's get started with the building. Make sure you have all your pieces. We're going to first work on constructing the sensor, then we'll build the robot, and then we'll attach the two and get started with the programming. So the first step, take your sensor, 2 double cross blocks and 2 black pins. Put each black pin into the pinholes of each of your double cross blocks. Taking 2 axle 3s, put the first axle in the left cross hole, and then put the other axle in the right cross hole of each of your cross blocks. So they're in different sides, and that way you can easily clip them on to the top of your sensor. Now taking a 5x7 frame, a size 5 beam, and 2 black pins, put both black pins in the 2 pinholes that are third from the top, and then insert your beam of size 5 across. And then you're going to attach the 2 black pins into the underside of that size 5 beam. And you want to make sure that the other half of the frame is facing the back of the touch sensor. And for the next step, once you've clipped that in, you're going to take 4 black pins and you're going to add them onto the top and bottom pinholes of the frame on each side. Now taking a beam of size 9, you're going to put the first pinhole onto the top black pin so that it sits across your frame. Now taking your T-beam and 2 beams with cross holes and a pin with ridge, put the pin with ridge through the middle pinhole of your T-beam, and then stick each beam with cross hole onto each side of your T-beam. And notice what direction I have the beam set, so they're aligned with your T-beam. Now taking an axle 12, put it through the cross hole. So you want your T-beam right in the middle of your size 12 axle. Now taking 2 pointers, you're going to put them on either side of your axle. And now taking 2 axle extenders, 2 axles of size 2 and an axle of size 3. Put an axle extender through one side So you have your axle 2 on one side of the axle extender. Put your axle 3 on the other end. Put that down and grab your other axle 2 and axle extender so it's clipped in. And you're going to want to put that through the remaining pinhole at the top of your T-beam. So you're going to insert the axle 3 into the pinhole and then secure it on the end with the other axle extender. And next you're going to attach this to the second pinhole from the end of your beam of size 9. And you're going to secure the front piece with a remaining axle, or sorry, once you have those two pieces, insert axle 2 into the second pinhole from the end of your size 9 beam. Take another size 9 beam, and we're just going to secure this piece in front by putting the axle into the second pinhole and securing it with the other black pins. So it should be symmetrical on both sides, and your T-beam should be resting right at the top of your sensor. And that's it for the touch sensor. We're going to attach this onto our robot, but first let's build the robot. So we're going to do it the same way that we've done before. You're going to start with 2 large motors, a frame of 5x7, put 2 black pins onto each side of your motor so you can clip your frame in. Turning it over, insert a frame of 5x11, and on each outside pinhole insert a pin with bushing. Once you've done that, take your 2 wheels and 2 axles of size 7, put them through the wheels, take a half bushing and put them through each axle, and then put that through the cross holes on the outside at the front of your motors. Now we're going to do the back wheel. So just like before, take 2 double cross blocks, 2 axle 3s, and your ball bearing with steel ball. That'll help our robot move backwards. So take your double cross block, put an axle 3 through each cross hole, put that through the ball bearing, secure it on the other end. Now take 2 black pins, insert them into the innermost pinholes at the back, and then you can attach the ball bearing by putting it through the double cross block pinholes. So it should be secured, and that will act as the back wheel to your robot. Now take 2 double pin connectors and 2 beams of size 7. Put each pin connector on either end. Put 2 black pins at the front of your frame where the 2 tires are, and then connect the piece you just built onto the 2 black pins. Now taking your cross blocks of size 3, place a black pin through each pinhole. And then put a blue Technic pin with axle into the cross hole. And you'll insert that at the back of your robot. And then inserting your last beam of size 7, put that on top of the blue Technic pins. And now for your black pins, you're going to put 2 on the side where your tires are, so ignoring the middle pinhole. And on the other beam of size 7, put a black pin through each pinhole except for the middle pinhole. So now we can attach our brick to our robot. And now with your 2 remaining black pins, we're going to add our sensor to our robot. So place 2 black pins at the back on the frame on the 2 outer pinholes. And you can now insert this onto the bottom line of pinholes of your robot. You could go ahead and turn on your brick at this point. And now all we have to do is attach the cables for the sensors and the 2 large motors. So we'll do the 2 large motors. Since they are motors, we're using the lettering side. So I'm going to use port B and C. Doesn't matter which port you use, just make sure that your program lines up with the lettering ports that you have attached for each motor. And then of course we got to add in a cable for our touch sensor. And because it's a sensor, we're using the number ports. So we're going to be using the other side of the brick. And I'm going to be using port 1. Again, you can use any of the number ports, just make sure that your program lines up with the one you have connected. So I'm using port 1. And we've completed the build for our robot. So with that, we're going to work on the programming. So the task today is to have our robot move and drive forward, but when we touch our touch sensor, and we press and release the touch sensor, it's gonna go backwards for 2 seconds. So that's the task at hand today. We're also gonna become familiar with the math block in the programming. So we'll be building 2 different programs and seeing how they react with our robot and the touch sensor. So for the first, you're going to grab the move steering block. Make sure that the ports line up with what you have here. So I have B and C. You're going to click on, and you're going to do a power for 50 for both of the motors. Then grab the weight block, and we're going to do touch sensor, compare, and you notice that there are 3 statuses for the touch sensor, which we talked about earlier. So there's released, which is 0, there's pressed, which is 1, and there's bumped, which is number 2. So the differences are release is when there's nothing happening. The touch sensor is not touched whatsoever. Number 1 is when you touch it. Immediately once it's touched, the robot will do something. And bumped means that the robot will do something once it's been pressed and released. So we're going to be working with state 1 and 2 for both of the programs. So for this one, put state 2, so that's bumped. And then once you've selected that, we want our robot to go back for 2 seconds. So do you know what block we're going to need to do that? Just grab the steering block and you're going to put on 4 seconds because we want to go back for 2 seconds. Put powers of -50 so that we can go backwards. If we were to put 50, then it would just keep going forward. So put -50. And then for seconds, we're going to put 2 because that's how many seconds we want to go back for. And that finishes the first program. And now we're going to build a second program. So this one is going to use the math block. So the reason the math block is so important is because we're able to control the speed of the robot using math operations. So you can take the math block and drag it in between the weight block and the steering block, the one when we're going backwards. So it'll be the third block in your line of the program. And then for the math block, for the value B, you can input -20. And then for the block A, what you want to do is drag the value of the touch sensor. So next to the state, there's an empty block. You're going to grab that empty block, drag it into the A block. And so do you want to guess what that will do to our robot? It will take the value 1, which is the state, or 2. So it depends what state you have set for your touch sensor. So on the screen you can see that we have the state 1. And that means that it's going to react once it's pressed immediately. And it'll take the number 1. And we have the math operation plus, so it's going to add 1 and -20. And the output is -19. And if we drag that empty block, the result of the equal sign, into each of the steering of the left and right motors at the last line of the program, then it'll take that number, which is -19, and apply that power to both of our motors. So the moment it's pressed, it's going to go back for -9 or for 19 because we're going backwards, so it's negative. So it'll go back for a power of 19. So you see that with the math block, you can control the speed of your robot depending on what state you have. I encourage you to play around with it and see what other things you're able to do using the math block. So now let's test out our program and make sure everything works. So I will put this aside. So we'll put the first one. What that's going to do is it's going to go forward for a power of 50. We'll bump it and it'll go backwards for -50. So it'll go at a speed of 50. And I'll do that for 2 seconds. So that'll be the first program. And we saw that that's exactly what it did. It went forward for 50. We bumped the touch sensor, so we pressed and released it. And then it went backwards for 2 seconds at a speed of 50. So now the next one, what we're going to see is the same thing, except this time we have a state of 1. And that means it's going to react as soon as it's pressed, so not when it's pressed and released, but just pressed. And it'll go back for the operation that we had in the math block. So the result of the math was -19. So we're going to go backwards at a speed of 19 after we press it, again for 2 seconds. So let's test that out. And there you go. So both our programs worked, and we saw how the touch sensor was able to allow our robot to detect objects. So instead of my finger, this could easily have been a wall, and the robot can now move backwards if it hits a wall, and we can even program it to touch the wall and then react and go around the wall. So it acts as the robot's hands. Now I want you guys to think of a question that I have for you, which is, even though we have the touch sensor already as a whole device, why did we add all these parts to the front of the robot? Why is this axle at the front important to have? It's what we mentioned it earlier, in that even though if it's a large object, it'll easily come in contact with our sensor here, but we want to make the surface area, the space that the touch sensor covers, bigger so that it can grab and detect all the objects in front of it. So if there's an object over here, then our robot can still bump it because it's still touching the axle, which then goes to our touch sensor. So a lot of robots that are built this way. They will add a piece in front of the sensor so that the robot can detect more objects. So that's everything for today's build, and we will see you for the next one. I've enjoyed learning about touch sensors with you guys. Once you're done playing with the robot, I encourage you to play around with the program, use the math blocks, see what more you could do with it. And once you're done with that, put your pieces away, and we'll see you for the next one. Bye, everyone.